All right, hello, my wonderful students. This is 7.2, foldable number 2. This one has 3 different things in it. So the title is going to be for each one, and that's actually what you would put on this side as well. The first one is actually be this one. So it's going to be rewriting an exponential function, and we'll go ahead and get to that one now. Zoom in a little bit. Bada bing, bada boom. All right, this one says the function p equal to 80 times 1.25d models the population of a city in thousands. Okay, after d decades, what exponential function models the population of the city after t years? So we're looking for the actual function that models the population of the city after the t years, and then it's asking for what is the annual growth rate of the city's population. All right, so we have the equation are kind of already set up for us. We have our, let's do it in, I guess we keep green. So we have our P is equal to 80 times 1.25, and then we have our D. Okay, but our D is going to be a little different because it's going to be based off of decades, right? It says right there, D decades. So I know a decade is 10 years. So our T, which is going to represent it, it's going to be our, how do we do this? But I think the best way to do it is to just do our 10D is going to be equal to the T. So it's going to be related, right? But we want to have this in terms of T. So what we're going to do is we're going to divide this by 10. And we're going to have our D, which we have there, is equal to, we can use 10 or T divided by 10, but I'd rather make it in decimal form, and I know that's 1 over 10, so it's going to be 0.1 T. If you get a calculator, just do 1 divided by 10, it gives you a 0.1% or 0.1 decimal, instead of being 10%, and then 0.1 T, that's what we're going to use. So we're going to substitute that in here, so go ahead and do that in blue now. So we're going to have P is equal to 80 times 1.25 times, or to the 1.1 to the T. Okay, so in order to do our growth model, we can't really use this, but what we can do is we can take, I forgot what the actual term is, but I know it has to do with powers. So if we have what we have right now, we have A, it's our B, but for this case it's A to the M to the N. What we can do is we can change to A to the M to the N power. So that's exactly what we're going to do. We're going to take P equals 80 to the 1.25 to the M, for this case, is to the 0.1 power, and then leave it to the T outside. So all we have to do now is take 1.25 and raise it to the 0.1 power. Well, I kind of did that already for you guys, so you guys wouldn't have to struggle. And I get that it's approximately, because it isn't an exact value anymore, 80 to the 1.023 power, or 3, now to the T. And all I did was I took 1.25 and I raised it to the 0.1 power. And so that's the number that's left over. So this is our simplified form of up here, after we substituted D for our value here. Now we can write our function. So let's do it in black. So the function P is equal to 80 times 1.023 to the T models. That's what we're looking for, right? Models the population of the city. I think it was in thousands, after T years. So all we really did is we basically converted our D here to a T and forms of the information. So we had decades, so we put 10 decades for the year and forms of T, and then since we need to get D by itself to substitute, we divided by 10 to both sides, got our D, substituted in what we had here, and kind of did the power rule here to get the power inside. Let's continue the thing, and then we got our new equation, which shows us the model. Okay, now the second question is asking what was the rate? Find the annual rate. Well, if you guys remember, the annual rate is actually in here, and inside the parentheses is usually, if I write the formula over here so you guys can see, it's a to the t is equal to a times 1 plus the rate to the t power. So we have 1 plus this rate here inside. So 1.023 is going to be equal to 1 plus our rate. So we're just going to subtract 1 to both sides, and we get our rate is equal to 0.023. But of course, we need a percentage because that's what our growth rate is going to be. So we're going to take this and we're going to go 1, 2, and we get that this is going to be 2.3%. So if we rewrite this here, we're going to have the annual growth rate is, I'll just put about because we did approximate over here. So we're going to say is about 2.3%. And once again, so that's, oh, wait, I guess this annual growth rate, it would be per year, but it's the annual growth rate. So we'll still put per year just in case they don't get confused.